And then in this lesson, we're going to review trigonometry that we've done in geometry. But sine, cosine, and tangent. uh, so first, let me explain. We have sine, cosine, and tangent. Those are our three terms we have. These only work for right triangles. Okay, only right triangles when we plug them in our calculator. We have a phrase that we use, so, ka, toa. And those are acronyms. What that means is sine, the S stands for sine, of theta, and I'll describe theta when we get to the next part, equals opposite, O stands for opposite, over hypotenuse. So, sine of theta in this right triangle, here's our theta. Theta refers to our starting point. That is where we start. So sine of theta equals opposite over adjacent. So what is opposite? What side is opposite of theta? Well, the opposite side of theta is A. So sine of theta equals A over what's adjacent. Well, notice there's two angles that are next to it, two angles that are adjacent. However, this one is the hypotenuse. If I could spell it right. That's the hypotenuse. So therefore, that is not our adjacent. B would end up being our adjacent for sine. So sine of theta in this one would be A over B. So if this was 7, so say B equaled 7 and A equaled 4, we would say sine of theta equals 4 over 7. And you could put that in your calculator and solve. Now let's look at cosine. Cosine, or ka, means adjacent over hypotenuse. So if we're looking at theta, cosine of theta, adjacent would be B, hypotenuse would be C. And then the last one is tangent, toa. Tangent equals opposite over adjacent. So opposite of theta is A. Adjacent to theta would be B. So A over B. So that's how you do these trigonometry. That's how you set it up. We aren't getting to the numbers quite yet in this lesson. We're just kind of doing the basics. Notice if theta was here, well, B would now become our opposite, A would become our adjacent. So just recognize that if your opposite and adjacent will change depending on which angle you use, where theta is, because that is your starting point. Okay, so that's how you do that. Let's say it said to type in, let's see what the book says. It says find cosine of 32. Or sorry, find cosine of 39.2 degrees. And use your calculator for that. You have to have a calculator for these. So I'm going to show you. All we would do is type in, and many of y'all know how to do this, but if we're finding cosine of 39.2, we would type in cosine 39.2. You can close the parentheses if you want, don't have to. And then you push enter, and then get your answer. Now you do have to make sure that you are on degree rather than radian. Have to be on degree, otherwise you'll get something different. So 0.77492. If it said type in tangent of 39.2. Well, here's tangent 39.2. I won't close parentheses this time, and I'll get that as my answer. It's a decimal, but that's how you type it in your calculator. There's one more thing that goes over in this lesson, and that's 43.2. And this is just using your calculator as well. 43.2 says to find an angle, or find angle A whose sine is 0.643. So this is having us work backwards. Well, if we know the angle, all we're going to do, referring to 43.2a, if we know the angle and we're trying to find the sine, what we're going to do is type in the inverse sine. Inverse of sine is the opposite. So what we would do is, notice this is the sine button. Right above it, if you can see it, there it says sine -1 in blue. So we want that. So we're going to type in second sine, and then the angle that it gives us, 0.643, enter, and our angle would be 40 degrees. So that would be angle A. Then it wants us to find the cosine, the angle whose cosine is 0.216. So we do inverse. Inverse cosine, so second cosine, 0.216. Enter, you get 77. If I typed in cosine of 0.216, notice that's not the same thing, not what we want. So you want the 77 degrees. Anyways, that's how you do the very basics of sine, cosine, and tangent.